So let's begin. I hope that you have practiced whatever we have done during the last weekend. What are the aims, goals and objectives as you can see on the screen? Brief revision, then today's topic, again we will do practice of the masses. Different kind of masses are there, molecular formula masses, and what else I can see on the screen, formula mass and molar mass, and the new topic of empirical and molecular formula. So as I told you, we are playing nowadays masses and masses. Okay, let's start. So what is the molecular mass, molecular formula mass? As you can see on the screen, it's not a new thing, it's revision, right? Carbon dioxide, it's a molecule. Okay, let me tell you, or rather remind you one thing. I told you, okay, unintentionally I'm heading towards the explanation of question number 4 of the assignment. All right. See, what are the elements of the group 1A? Lithium, sodium, potassium, rubidium, cesium and francium. And then for group 2, beryllium, magnesium, calcium, strontium, barium and radium. If you see any one element in the formula, like NaCl, Na is here, from these two groups, it means that these two groups, as I told you earlier, these two groups won't form any molecule. They do not form any molecule. They form a different kind of compounds. Okay? Those are called ionic compounds. So you see sodium over here. So it means it's not a molecular compound. It's just an ionic compound. Okay? Similarly, what do you think? Carbon dioxide. What do you think? Carbon dioxide. Can you see any of these elements? No. Then it's a molecular compound. Remember, both of these are compounds. Okay, this is compound, this one is also compound. What I am trying to convey you, this is not a molecular compound. Why? Because it contains an element from these two, especially. These compounds, these elements do not form molecular compound. So this one is not a molecular compound, this one is a molecular compound. This one is not a molecular compound, this one is a molecular compound. See another one. HCl. Can you find any of these elements over here? No. It means it's a molecular compound. Can you find an element? Yes, potassium. So it's not a molecular compound. Okay. Similarly, if you see potassium iodide, so it's very clear that potassium belongs to these two groups. That is why this one is not a molecular compound or covalent compound, but an ionic compound. See this one, NH3. Can you find N over here? This is Na. N. No, it means it's a compound. It's a molecular compound. It's a covalent compound. I repeat, all of these are compounds. Then there are two types of compounds. One, The molecular compounds which do not include any one of these elements. The other ones are the ionic compounds which contain any one of these elements. Like this one is an ionic compound. Like this one is an ionic compound. Like KNO3, it's an ionic compound. Like CaCl2, it's an ionic compound. All right, it's not a molecule. Not molecule, not molecule, not molecule, not molecule. Now the next part. I hope you understand. You have understood now that there are two types of compounds: ionic compounds in which there isn't any formation of molecule. The other ones are molecular compounds, or they are more specifically called covalent compounds. Two types of compounds. Next, if we find the mass of this one, we call it molecular formula mass. Molecular formula mass, or simply molecular mass. Molecular formula mass. Okay? Now, the next question is, NaCl. Clicked. Na over here, it means it's not a molecular compound. If it's not a molecular compound, then we can, suppose we find its mass. What is the mass of sodium? 23 into 1. What is the mass of chlorine? 35.5. I'm talking to those who have practiced these masses during the weekend. If you didn't, you won't be able to understand it. Simple. Adding these two, 58.5. Now, what do you call this one? If I call it, its molecular mass is 58.5, then you will say, sir, it's not a molecule. How can you say its mass is molecular mass is 58.5? Then what else should we call it? We will call it formula mass. What will we call it? Formula mass. Okay? So the term formula mass is specifically used for non-molecular compounds, for ionic compounds, for those compounds in which there isn't any formation of molecules. All right? Okay, let me tell you one more thing. Calcium chloride. Let's find its mass. Calcium 40. How many calciums? Just one. So 40 into 1. I'm not writing 1 now because I think that you have grown up now in chemistry in this topic. Plus, what is the mass of single chlorine? Who remembers? Good. 35.5. How many chlorines? What is the subscript here? 2. 40. When you multiply these two, you will get 71. So what is the mass? 111. Is it a molecular mass or formula mass? Check the formula. Calcium. Calcium is there in the table, that the group that I just mentioned. It means it's not a molecule. So if I say its molecular mass is 111, I will be wrong. What else we call it? We call it formula mass. Okay, see another example. These are just the common examples. If you know it, if you have practiced during the weekend, all of you must be understanding that what I trying to convey over here. See another example like NH3. What do you call it? NH3 ammonia. Nitrogen 14 times 1. I'm not writing 1. Plus hydrogen. What is the atomic mass of hydrogen? 1. How many hydrogen do we have? 3. Now, I'll ask the same question again. Is it correct to say molecular formula mass for ammonia? Yes, because it doesn't contain any of those elements: lithium, sodium, potassium, rubidium, cesium. You should just learn the first three. And this other group: beryllium, magnesium, calcium, strontium. There are some exemptions. Okay, we are not talking about those exemptions. All right. So I hope that you understood that what is the difference between molecular formula mass and simply the formula mass. Okay, molecular mass can be we cannot use for ionic compounds. Now a point, you must have heard this: all mangoes are fruit, but all fruits are not mangoes. Okay, same will apply over here. Means the term molecular mass we won't use for ionic compounds. Done. And but the term formula compound you can use not only for calcium chloride but also for ammonia. Means if I say the molecular mass of ammonia is 17, fine. But if I say the formula mass of ammonia is 17, this will be also fine. Okay, I repeat, we can use both the terms for molecular compounds: molecular formula mass or simply formula mass. But for this one, which is ionic, we will not use molecular compound. And now the last point. What is the unit of molecular masses or formula mass? AMU. And finally, after this, instead of writing AMU, if I write G, I am representing its mass in grams. Then it will be called gram molecular mass, or simply the new terminology, molar mass. See, carbon, atomic mass of carbon is 12 AMU. I told you that we practice it, and this is its atomic mass, comparative atomic mass, relative atomic mass. If you replace this AMU by G, it will be called gram atomic mass. And what is the new term for it? Molar mass. So molar mass means molar mass is a general term which covers all the other masses. Okay, so you can see the definitions. There's a big difference in explaining these masses. And just to rectificate,